what does Kubernetes offers for various frameworks that are used in the data processing workloads. So before we get started, let's first understand what are the various challenges we face when running the data processing workloads in the clusters in general, right? So one of them is highly scalable requirement. So which means the workload needs to scale to thousands of nodes in a short span of time. So that means the platform needs to scale to those many instances as quickly as possible to achieve the SLAs. So that is one important criteria. And then it needs to be designed from a high availability and the failure point of view as well, because the nodes may be terminated, the ages may be down. So all of these use cases needs to be covered from an availability and reliability point of view. One more challenge is basically to monitor these applications which are running at scale. And the monitoring stack should be able to support the logging and the metrics and the traces. And it has to support both the applications at scale and also the underlying infra as well. And another important criteria is basically the network topology. If there are thousands of pods or the workloads nodes running, then do we have the enough IP space available in the cluster? And is there a limitation on the shader blocks? And what should be the right approach is something we need to design. And choosing the right compute and storage is also very important because it requires the cost analysis and also the latency and the throughput implications are involved when choosing the right compute and storage for these data processing workloads. And last not but the least is basically on the scheduling side. Sometimes the default scheduling is not enough, so that means we may need to go for additional customized schedulers for example, the batch scheduler options we need to use for certain use cases. So all of these are typical challenges that we face when you deploy data processing workloads. Now, let us understand why Kubernetes in the first place to address these challenges. So one of the things what Kubernetes provides is a scalability. Kubernetes is designed to scale into thousands of nodes and the pods in a very short span of time. And scalability is one of the core tenets of Kubernetes. And the second one is a powerful orchestration by using all the control plane, the data plane components in the cluster. The efficient bin packing, scheduling, the management, the declarative nature, all of that is provided by default in Kubernetes. And the third, another important criteria is basically the portability, because when you have application deployed in one Kubernetes based platform, it's easy to port across the platforms, be it on-prem or the cloud or the hybrid model. So portability is very important. And many organizations use Kubernetes based platforms to standardize across different teams and the BUs within the organizations. So this will allow the DevOps teams to provide a single consistent tooling for their development teams and different business units so that they can leverage the same clusters for various applications. Now, we discussed what exactly Kubernetes offers in general. Now, let us see why Kubernetes for the data processing. So in terms of the scalability, we discussed Kubernetes inherently designed to handle at peak scale, and it also provides a better resource utilization by doing the bin packing, selecting the optimized instances for the workload, and all of that is taken care by default, and also provides a lot of flexibility in terms of using the graphics or any GPUs or any other accelerator instances and optimized storage into the workloads. And many teams can leverage the same existing Kubernetes cluster, and they can work independent of each other in their respective namespaces. And Kubernetes does provide a powerful set of tools with respect to monitoring. It could be managed or self-managed. So for logging, metric, and tracing, there is an ecosystem of tools available in Kubernetes. And portability we discussed already. once a application is deployed in Kubernetes, it can be portable across various Kubernetes-based platforms, on-prem, cloud, or hybrid model. Now, Kubernetes also provides a lot of options to integrate multiple storage and the computing options through a concept called CSI drivers. So we can have a dedicated drivers for example, EFS, FSX cluster based file systems, EBS, and for various computing infra as well. And also very cost effective because it allows to use multiple instance types, be it Spot or be it bin packing, optimizing the space on the instances. All of this is inherently supported in Kubernetes. And there's a vibrant ecosystem of partners, developers in the open source community to provide a lot of tools and frameworks for data processing in Kubernetes. So these are some of the important criteria why Kubernetes is typically chosen for data processing workloads. Now let us understand a little bit of on data on EkS project, which is a open source project focused on creating data platforms on Kubernetes. So the data on EkS projects, one of the things it provides is the reference architectures. There are many vetted reference architectures available across various use cases, be it AML, Spark workloads, distributed queries, schedulers, and things like that. So customers can leverage these reference architectures as a standard base and then build on top of it and customize for their production use cases. So it reduces the time that is spent on the customer side to get started. Second, it provides a lot of reference infrastructure as code templates, be it Terraform or CDK, so that customers can get started quickly and customize further for their specific use cases. And all of these reference architectures and the templates are built on top of the best practices in terms of the compute, storage, networking, and so on. So that means customer doesn't have to really worry about choosing a specific feature and the right approach because all of them are baked into these reference architectures by default. So it easy for them to adopt and also provides a lot of sample code for various use cases so customers can leverage this right away and build further on top of it. Now let us look at some of the areas which data and EKS currently focuses. For example, one of the primary focus is artificial intelligence and machine learning. So in this case, it provides many popular frameworks. For example, it could be Kubeflow, Jupyter Hub, MLflow, Ray. Trainium is hardware accelerator provided by AWS to train the models, and Inferentia is one more chip focused for Inferentia, that is inferencing workloads at scale and at a reduced cost. And there are a lot of NVIDIA based graphics, EC2 instances are available for training and inferencing as well. So all of these are provided through the AML workload. And one more workload is data analytics. And in this case, there are popular open source frameworks which are Apache Spark. And to use that, we have Spark operator that is deployed in the Kubernetes to submit the Spark jobs and run the driver and the executor parts. Then apart from Spark, there are also popular other frameworks like Dask, Beam, and Pandas. Then there are some schedulers for custom scheduling like batch scheduling options which are Unicorn and Volcano available as well. Another workload is basically EMR and EKS where customers can leverage the existing EKS clusters to run their EMR Spark jobs in Kubernetes apart from the other business applications. Both applications can share the same cluster resources. And Carpenter is a very powerful recommended open source cluster autoscaler for Kubernetes. And we can leverage a multi-tenancy which Kubernetes provides in terms of the namespaces to run Spark applications of different versions from different data science teams or the data engineering teams. One more area is the streaming data platforms. This is where many popular frameworks such as Kafka, Flink, and Spark streamings are supported. It also includes some reference architectures based upon Apache NiFi as well. Then comes the job schedulers. This is where we need a powerful orchestration workflow manager. For that, we have options for like Apache Airflow or AWS managed Apache Airflow version as well. And we can also use Argo workflows for the workflow management. Then for the distributed databases and queries, there are quite a few options there in terms of Cassandra, Trino, and Presto. Let us understand how a typical open source software based data platforms looks like in Kubernetes or Amazon EkS. Let's get started. Let us say we have an Amazon EkS cluster. Let us start with the job schedulers. So these are the components which are required to submit the jobs and manage the workflows. So the data engineers or the data scientists submit their data processing workloads through these job schedulers. So some of the options in this category is Apache Airflow and Argo workflows. There could be others as well, but these are the populars in this category. So the job schedulers submit the jobs to the cluster, and that's where we have the schedulers coming into picture, which will orchestrate the scheduling of the required components to execute that application. So we have Volcano and Unicorn in that category. And you can also leverage the Kubernetes default scheduler as well for most of the use cases. But these batch schedulers can be leveraged for a special purpose use cases where certain functionality is required, such as gang scheduling, for example. And then comes the data ingestion. So when the application is running in the cluster and it needs to have the input data that can be hosted in different data sources. For example, the Kinesis could be one of the option for ingesting the data, or it could be Kafka as well. Then we have the actual workload running, which is where the data processing is happening. It could be batch processing or the streaming processing applications. So this is where the Spark comes into picture, which is very popular open source framework. And we have Dask, then Flink, Pandas, and other frameworks like Beam is also available in this category. Then we also have certain workloads which are for querying the data. So this is where the Spark provides a Spark SQL library, which provides the querying capabilities. And there are some other options for example, Trino and Presto also into this category for querying the data. Then we have some data visualization tools like Superset is one of the popular open source framework out there. Then in the AML space, we have quite a few famous and popular frameworks like Ray, MLflow, and Jupyter Hub and Kubeflow. Then we also need to have some data stores or OLAP based platforms for storing the data. It could be Cassandra, or it could be Pinode, or it could be a PostgreSQL. There could be many other options, but these are some of the popular options out there in this category. Now that we discussed various workloads that could run in the EKS cluster, but what's important here is the underlying computing and storage platform is very much important to host all of these workloads. So that's where let us look at the storage options first. So from the data lake and storage perspective, most of the times Amazon S3 buckets are used for storing the input and output data and also for hosting the machine learning models and the training data as well. And for high performance, we have Amazon FX Lustre series of file systems for high throughput and low latency use cases. Then we have Amazon EBS for dynamically created PV and PVCs for the executors. Then we do have popular databases like Amazon RDS and DynamoDB for the respective use cases. For the computing infra, we have many options. So starting with the Amazon EC2, so this is where you can run the core workloads which are non-data on EC2 machines, and the data workloads could be running on, for example, Spot. For example, the executor pods can run on Spot to save cost. Then we have specialized instance types, which is Inferentia for inferencing workloads at scale at reduced cost. And there is also a specialized hardware accelerator instances, which is called Trinium for running the training for the models. Then we also have a lot of NVIDIA-based GPU instances for training as well as inferencing the models. So here we just provided very few popular open source frameworks for creating a end-to-end data platform on Amazon EkS, and also spoke about the required storage and the computing options as well. Now, based upon the use case requirements, so some of these frameworks in the respective sections can be stitched together to create a end-to-end data pipeline on EkS.